Principle of orbiting satellite. A satellite is a natural or an artificial body orbiting around another body of larger mass and larger radius. Moon is a natural satellite of Earth. You are aware of communication satellites orbiting the Earth. Since these are man-made, such satellites are called artificial satellites. How do we place such an artificial satellite in an orbit around the Earth? Imagine that you stand on the roof of a tall building or tower. If you freely drop a stone from it, it will fall on the ground along a straight line path 1 in figure. However, if you stretch your hand horizontally and throw the stone with some speed, then stone will reaches the ground and touches the position A but following a curved path 2. Now if you can throw the stone horizontally with higher speed, the stone will fall on the ground at a further point B by following a less curved path. We conclude that faster the initial horizontal speed of the stone thrown, greater is the radius of the curved path. What would happen if we increase this radius of curved path such that it is equal to the radius of the Earth itself? The stone would no more fall onto the Earth, because as it falls towards the Earth also curves down by the same amount. The stone's distance above the surface of the Earth remains the same and it continues to orbit around the Earth and thus becomes an artificial satellite to the Earth. Using this principle, artificial satellites are sent into the orbit around the Earth. Note that initially the motion of the stone or satellite is tangential to the Earth's surface. It revolves around the Earth because of centripetal force provided by the Earth's gravitational pull. The principle of launching an artificial satellite into a proper space orbit is to impart sufficient initial horizontal speed such that it revolves around the Earth at the